Did you know that there are 7 different stages of artificial intelligence? Given the exponential growth and importance of technology, it's crucial to understand how far we've made it on the journey to AI. In this video, we'll break down the 7 stages of AI, tracing its evolution from its humble beginnings to the potential future of superintelligence. So without further ado, let's jump right in. Stage 1. Rule-based AI Systems. In the early stages of AI development, rule-based systems were the primary approach used to build intelligent systems. These systems relied on a set of predefined rules and logical statements to make decisions or perform tasks. The rules were typically created by human experts in a specific domain and encoded into the AI system. Picture playing chess against a computer. Every move it makes, every strategy it deploys, is governed by a predefined set of rules, its algorithm. Rule-based AI systems, also known as one-task systems, are excellent at tasks with clear-cut rules, like diagnosing mechanical issues or processing tax forms. But their capacity to learn or adapt is non-existent, and their decisions are only as good as the rules they've been given. Consequently, they require constant manual updates and maintenance by experts to incorporate new knowledge or handle complex scenarios. Moving on to Stage 2, we have context awareness and retention systems. As AI progressed, researchers realized that rule-based systems had limitations in handling real-world complexities and dynamic environments. This led to the development of context awareness and retention systems, which marked an important step towards more advanced AI. Context awareness refers to an AI system's ability to understand and respond appropriately based on the context or situation it is operating in. These systems incorporate various techniques such as natural language processing, computer vision, and machine learning algorithms to analyze data from multiple sources and extract relevant information. Like your smartphone assistant, Siri, or Google Assistant, these AI systems remember past interactions and use that knowledge to shape future responses. If you ask who won the football game yesterday and then ask when is their next match, the system understands that "there" refers to the football team from your previous question. This is made possible using techniques like reinforcement learning, deep learning, and neural networks that allow the system to learn patterns from large datasets. These systems are like teenagers in the AI development stages, beginning to understand context, but still far from independent thinking. Stage 3. Domain-specific mastery systems. In this stage, AI systems are designed to excel in specific domains or areas of expertise. They are trained to become specialists in a particular field, similar to how humans specialize in different professions. These AI systems acquire vast amounts of knowledge and skills related to their specific domain. They can analyze complex data, identify trends, and provide valuable insights or recommendations. Imagine IBM's Watson, designed to excel at answering questions on the quiz show Jeopardy, or Google's DeepMind AlphaGo, which is trained to master the complex board game Go to the point of defeating world champions. These AI systems are the adults in the room, demonstrating sophisticated abilities within their specialized fields. They are highly efficient within their domain, but they may struggle when faced with tasks outside their expertise. They lack the ability to generalize knowledge across different domains or think critically like humans do. Stage 4. Thinking and Reasoning AI Systems. In this stage, we see AI systems begin to mimic human-like thinking and reasoning abilities. They go beyond being domain-specific specialists and strive to understand concepts, learn from experiences, and make decisions based on logical reasoning. Thinking and reasoning AI systems don't just follow rules or retain context. They simulate human thought processes. Imagine an AI system reading a book, understanding the plot, and inferring the characters' motives based on their actions. Or consider it analyzing economic data, anticipating market trends, and suggesting investment strategies. It's like a highly advanced tool specialized in reasoning and thinking tasks. It can understand context, interpret ambiguous information, solve complex problems, and engage in meaningful conversations with humans. These AI systems have the potential for creativity and abstract thinking. They can generate new ideas or solutions by combining existing knowledge in innovative ways. However, achieving true thinking and reasoning capabilities is still a significant challenge for AI researchers. While progress has been made in specific areas like natural language understanding or game playing, developing general-purpose thinking machines that match human intelligence remains an ongoing pursuit. Stage 5. The birth of a new mind, artificial general intelligence, AGI. As we step into the realm of artificial general intelligence, we're entering a world of AI that for now remains largely theoretical. An AGI system would be capable of understanding, learning, adapting, and implementing knowledge across a broad range of tasks, just like a human. If you asked an AGI to learn a new language, write a symphony, derive a complex mathematical theorem, or even understand human emotions, it should theoretically be able to do it. It would possess self-awareness, consciousness, and the ability to understand and navigate the world. AGI systems have the capacity to not only specialize in specific areas, but to also adapt their knowledge and skills to new situations. For example, an AGI system could be trained to excel in multiple fields such as medicine, engineering, and art. It can analyze data from different sources, make connections between seemingly unrelated information, and generate new ideas and solutions. However, AGI remains a concept and has not been achieved yet. It's the frontier of AI research, and it's also where things begin to get controversial. Because what happens when AI matches human intelligence? What comes next? Well, let's find out. If you thought the previous stages were intimidating, you ain't seen nothing yet. Stage 6. Artificial superintelligence, ASI. This is a level of artificial intelligence where things get really complicated to the point where it's difficult to say what AI is and isn't, due to the fact that an ASI system would possess cognitive abilities far superior to our own. ASI represents a world where AI would be capable of outperforming humans in every aspect of intellectual and economically valuable tasks. It's not just about being able to do everything a human can do, but doing it better, faster, and more efficiently. To understand the level of intelligence of an ASI system, imagine a human being the size of an ant in comparison. An ASI system could potentially solve problems that humans can't, coming up with solutions to complex global issues like climate change. It could innovate and create in ways we can't even imagine. It could potentially provide insights into the mysteries of the universe that are currently beyond our comprehension. However, it's important to note that the advent of ASI also brings a host of ethical and safety concerns, raising fundamental questions about power, control, and the very nature of intelligence and consciousness. The prospect of ASI takes us into the realm of the unknown. It's at this point that we encounter the final stage of our journey. Stage 7. The AI Singularity. A hypothetical point in the future when technological growth becomes uncontrollable and irreversible, leading to unforeseeable changes to human civilization. The term singularity in this context was first introduced by mathematician and computer scientist Werner Vinci in 1993. It's drawn from physics, where the singularity represents a point, like the center of a black hole, where rules as we know them seem to break down. In the context of AI, the singularity represents a point in time when an ASI is not only smarter than humans, but also capable of continually improving itself at a rate far beyond human capability. It can rewrite its own code, optimize its algorithms, and enhance its hardware capabilities. As a result, it becomes even smarter than before. With this increased intelligence, it can further improve itself at an even faster rate. This cycle continues with each iteration resulting in an exponential growth of the AI's capabilities. This self-improvement could potentially cause an explosive acceleration in technological advancement. The singularity is often associated with dramatic predictions, such as the end of humanity, the ability to upload human consciousness into a computer, and the potential for massive societal disruption. It's important to note that the concept of the singularity is still highly speculative and controversial. Some believe it will happen within a few decades, while others think it may never occur. But regardless of where you stand on the possibility of the singularity, contemplating the potential impact of superintelligent AI helps us explore both its promises and challenges for our society. As we look to the future, one thing is certain: the role of AI in our world will only continue to grow. Thanks for watching.